Hello everyone. So today we are going to learn about supermesh analysis. So what is a supermesh? The meshes that share a current source with other meshes and none of which contain a current source in the outer loop form a supermesh. For example, suppose if we are having a circuit like this. So one second. So this is a resistance. Then this is, suppose we are having a current source here. This is a voltage source, and then if we have to write down the equation for this circuit, then what we can see here is these two loops or these two meshes are sharing a current source in between them, and there are no other current source in the outer loop. Okay, so if this type of situation arises, then we call it as supermesh. Okay, so let us consider a numerical and see how we can solve this supermesh analysis. Okay, before going into numerical, let us first understand. So in this case, we cannot write down the equation for loop 1 or loop 2 because we are having a current source in between. So in this case, what we do, we write down the equation or replace the equation by a KCL equation at the node. For example, suppose we can consider this node, then we have three currents, right? So suppose this is your I1, this is your I2, and this is suppose 5 ampere. Then what we will be having is I1 plus 5 equals to I2, right? So this KCL equation will give you one equation, and second equation will be your KVL equation, which will be writing in the outer loop. So for example, it will be, suppose this is your V1, then it will be V1, then minus of suppose R1, R2, R3. So it will be minus of R1, I1, then minus of R2, I2, then minus of R3, I3 equals to 0. Okay, so these two KVL equations are getting replaced by two equations, out of which one is the KCL equation at the node and second one is the KVL equation in the outer loop. Okay, now here, as we have written KCL equation in this node, we can also find out the KCL equation in this node, and it will be same. As you can see here, this is your I2, this is your I1, and this is your 5 ampere, right? So then we can see one current is moving inside, two currents are moving out, so it will be obviously I2 equals to 5 plus I1, which is nothing but same as our first equation. Okay, so this is how we solve supermesh or we do supermesh analysis. Okay, so let us see a numerical. So suppose we are considering this numerical. So in this case, as you can see here, we have three loops, and in that three loop, these two loops are sharing a current source. So these two loops constitute a supermesh. Okay, so in this we can directly write down the equation for mesh 1. So for mesh 1, if we write down the KVL equation, sorry about my handwriting, so KVL for mesh 1, so it will be minus of 2, sorry, it will be plus because we are moving from negative to positive, so it will be 2, then minus of 1 into I1, then it will be minus of 10 into I1 minus I2 equals to 0, right? Then coming to your supermesh, so as we have discussed, for supermesh we'll be writing down KCL equation. So suppose in this node we are writing the KCL equation. So this is my current I2, this is my current 4 ampere, and this is my current I3. So at super node my KCL equation is, so at super node my KCL equation is given by I2 plus 4 equals to I3, right? So this is my KCL, and my KVL in the outer loop will be, so starting from this point, then this will be minus of 10 times I2 minus I1. We write it normally as we do in case of our KVL equations. Then minus of 5 times of I2, then minus of 15 times of I3 equals to 0, right? So we have three equation, three unknown. Now if we solve, then we get the values. So value after solving, we will be finding it as I1 equals to minus of 2.35 ampere, I2 will be equals to minus of 2.78 ampere, and I3 will be equals to 1.22 ampere. Okay, so it is as simple as that, right? So supermesh analysis is what? Nothing but whenever we have two meshes that share a current source in between them and there are no current source in the outer loop, then it is called as supermesh. Okay, so whenever you go for solving any numerical from now onwards, just check whether you are having a supermesh in your circuit or not. If there is a supermesh, then instead of writing KVL equation, we have to write both KVL and KCL equations. KCL equation across the node and KVL equation in the outer loop. Okay, so now let us consider another numerical which contains a dependent source, right? In last class we have discussed about dependent source, and we have also said that in the next class we will be considering supermesh analysis containing a dependent source. Okay, so now here as you can see, current directions are already given, that is your I1 clockwise direction, I2 clockwise direction, and I3 your clockwise direction. Okay, so now in the first loop there is no issue, we can directly write down the equation, right? So if we write, it will be 110 plus, then minus of 14 times I1, then minus of 4 times I1, then minus of 2 times I1 minus I2, right, equals to 0. Okay, then coming to the second two loops. So in these two loops, as you can see, this is a voltage dependent current source. So see, this is a current source which is in between two loops, so we cannot write down KVL equation directly. So what we have to do, this is a super mesh, so we have to write down KCL equation and KVL equation in the outer loop. Okay, so which one will be outer loop? So outer loop will be this one, right? This one is your outer loop, and we'll be writing KCL equation across this node or this node. Okay, so as you can see here, this is current I2, then across this is current I3, and this is your 0.5 V1, sorry, this is V. Okay, so this is your KCL equation. So if KCL equation we write, so I2 is moving in plus 0.5 V1 is moving in, right, equals to I3. Okay, so what is V1? V1 here is nothing but V1 equals to this voltage drop, right? So V1 is in this direction, so we can write it as 2 times of voltage. V1 is 2 times of I1 minus I2, right? So V1 is 2 times of I1 minus I2. So here will be this equals to plus 0.5, V1 is 2 times of I1 minus I2 equals to I3. Okay, so we have one equation, we have second equation, right? So next, for our third equation, we will be requiring the outer loop KVL. So this is my okay, let me write it properly. So this is my KVL in mesh 1, this is KCL in super mesh, and then next is your KVL in super mesh. Okay, so now it will be, if we start from this point, then it will be minus of 2 times I2 minus I1, then going to this minus of 10 times I3, then finally minus of 6 times I2 equals to 0. Okay, so we have three equation, three unknown, and after solving what we get is I1 equals to 5 ampere, I2 equals to minus 5 ampere, and I3 is equals to I1, and I1 equals to 5 ampere, so this is also 5 ampere. Okay, so this is as simple as that. So whatever we have discussed today is supermesh analysis, and we have discussed supermesh analysis with respect to normal independent sources. Sorry about these two lines. So we have discussed supermesh analysis with respect to dependent sources, and we have also discussed supermesh analysis with respect to independent sources. Okay, so I guess you have understood this. So we will join again in our next class. So thank you for listening.